So welcome to Everyday Mathematics. Here at Everyday Mathematics, as we always say, we do enjoy solving the harder problems, but above all, we also see and appreciate the beauty in the simpler problems. Now, today's problem comes from the MIT 2024 Integration B Quarterfinals Tiebreakers. Problem number 2 is what we're going to be focusing on today, and it is the limit as t tends to infinity of the integral from x equals to 0 to x equals to 2 into brackets of x to the power negative 2024t times the product from n equals to 1 to n equals to 2024 of sine into bracket n times x to the power t, close bracket and close the bigger brackets. So this is our problem. Very interesting. I love it. Now, before I jump into the solution for this problem, I'd like to thank our subscribers. Thank you so much for the great support. We don't take the support for granted. The support means a lot to us. To our first-time visitors here at Everyday Mathematics, what we do is we go about and around and look for problems as these that are interesting, and we come around and we share with you our version of the solution. And to our repeating visitors who haven't subscribed to our channel, please, we do really encourage you to consider subscribing to our channel. Your support will really mean a lot to us. It will give us that extra visibility we need. So how do we solve this problem? The first step is in just expressing it in a way that is easy to comprehend. So what I did was just to remove this bigger product sign here and express the individual elements just in a way that can allow us to picture things. So we have, first of all, this x to the power negative 2024t can be spread across all the product items or elements in this product term. So we have sine of x to the power t over x to the power t, sine of 2x to the power t over x to the power t, continuing all the way to sine of 2024 xt over to the x to the power t over x to the power t. So we have these 2024 different elements multiplied together. The first thing that at least I could visualize here is I see for the limit t tending to infinity of this x to the power t, you see that it tends, x to the power t tends to 0 between 0 and 1. But between 1 and 2, this tends to infinity. So I'd like to divide this integration into two different integrals, between 0 and 1 and between 1 and 2. Okay, so that's what we've done, right? Now going forward, since that's what we've gotten, the important thing to note here is that since these independent functions here are continuous in both the intervals, we can now go ahead and take the limits as t tends to infinity of the independent product elements, and without losing the generality, or without losing the intention or the answer of what we are trying to aim at. So we've taken this limit and we apply it to the individual elements as shown here. Okay, then going forward, as we stated previously, between between 0 and 1, the limit x to the power t is 0, so as t tends to infinity. And then between 1 and 2, when t tends to infinity, x to the power t goes to infinity as well. So the important thing here, since this x to the power t tends to 0 and sine x to the power t, that sine 0 tends to 0 at that point, the denominator also tends to 0, we are going to have to employ a L'Hopital rule for the top integral. And since sine x to the power t, even if x to the power t tends to infinity, it still oscillates between -1 and 1, yet the denominator here tends to infinity. We'll see that these individual terms tend to 0, right? Because the numerators at any point will just oscillate between -1 and 1, +1. So this lower term here would be 0 times 0 times 0 times 0. So effectively, our integral here reduces to only us focusing on the first integral. And we're going to make that a little bit more clear as we go along. So since this is our integral, and as we said, using L'Hopital's rule for the interval x, when x is between 0 and 1, and also noting that between that sign n, that the x to the power t, that is n could be 1, it could be 2, it could be 2024, noting that this function here oscillates between -1 and 1, yet x to the power t tends to infinity in that interval, the lower interval 1 to 2, then we're just going to simplify things. Our integral here degenerates into this. So we've used the L'Hopital rule, and we got in the first derivative with respect to x to the power t of the numerator and denominator. And now we see that the denominator disappears because it's just 1. And so we are left with cosine x to the power t limit with x to the power t tending to 0, 2 cosine 2x to the power t with x to the power t tending to 0. And what this other term here becomes 0, 0, 0, 0. So here, as x to the power t tends to 0, cosine of 0 is definitely 1. And this, since this is 1, as this tends to 0, and we're left with this constant 2, and that continues up to 2024. So we have a product of 1 times 2 times 3, all the way to 2024. Yet this one, this entire term goes to 0, right? Now we're left with the integral of 2024 factorial from x equals to 0 to 1. And we integrate that, we get x with the appropriate limits, 0 and 1. And that means that our answer now, our final answer is 2024 factorial, which is the constant here. And that is our answer. So guys, thank you so much for hanging around with us. I'm beginning to feel better. So yeah, it was an absolute pleasure hanging out with you, solving this problem. If you do have any questions or an alternative way of looking at this problem, we do welcome your input and your suggestions here. We do welcome any form of input. We're here to learn, we're here to grow, and we're here to share. Thank you. Until next time, adios.